These two things combined weigh more than 2,000 pounds. That's more than a first-generation Mazda Miata. And I need to get both of these into my room. And once it's in there, it's gonna be an insane challenge to try and figure out where to put them so that my room isn't completely filled up by just two machines. But I can't even get to that challenge because right now, neither of these roll. So this entire episode is dedicated to getting casters onto both of these machines so we can get them into the room. And I realize that doing an episode purely on casters might seem a little boring, but you know, this is real deal work. This is part of working with heavy equipment like this, but also the challenges that I think we have to overcome on the Bendix G-15 here is pretty interesting. So I figured I'd bring you guys along for the journey. And we got to start with this big beast first because, well, both of these require a forklift to pick them up, and this one is physically in the way of the G-15, so we got to get it squared away first so I can roll it out of the way and get the forklift over to the G-15. And if you're looking at this going, what on earth is that? I've never seen that on the channel before. Well, it's a brand new acquisition. I got it here like 2 days ago. And it looks like a scanning electron microscope, but it is not a scanning electron microscope, even though it can do the same job as a scanning electron microscope, but not as good as a scanning. It's a JEOL JAMP 10S, which stands for Auger Microprobe. Now, quick aside, because I can already hear the keyboard warriors going insane about my pronunciation of the company name, JEOL. JEOL stands for Japan Electron Optics Laboratory, but the company's real name is Nihon Denshi Kabushiki Gaisha. They created the JEOL name in the late 60s or early 70s as a way to create international brand recognition. And so it's supposed to be pronounced like JEOL, which is the katakana way to pronounce it. And even that I'm probably getting wrong slightly. But what is an Auger microprobe? Well, Auger is the last name of Pierre Auger. Again, I'm probably pronouncing that incorrectly, but Auger was a brilliant scientist that discovered the Auger electron, which is an electron that gets emitted. I'm not going to go into the full science of it here, but essentially you have an electron gun blasting a sample that you're testing, and you can detect specific electrons flying off of that. And this is very good for surface analysis of a sample. But because we're blasting that thing with electrons, we can also detect the reflected back electrons. So this can do electron imaging like a scanning electron microscope, just not to the resolution of a dedicated SEM. But it can also give us information about the molecular composition of a surface material, like maybe a magnetic coating on a disk platter or maybe a rotating drum memory. So I'm incredibly excited about this machine, but it weighs in at like 550 kilograms, which is like chasing down 1,300 pounds. So in order to get this thing into the room, I gotta put wheels on it. Now, before you go crazy about saying how this thing is not supposed to be on wheels, you're absolutely right. Any kind of vibration in this thing can destroy your image quality because we're talking about magnification down to something like 20 nanometers. So what you're supposed to do with this thing is put it on rubber isolators. And I have those rubber isolators, but until the point at which we have this thing fired up and we're ready to start taking serious measurements, I'm gonna need to pull it out from the wall, turn it around, move it around the room a bunch. So for now, we're just gonna put some big chonky casters on it. And once we're at the point where we're ready to do real deal science with this thing, we'll jack it up, pull these off, set it down on proper rubber isolators, and do the real science that way. These are 375-pound casters. I kind of went a little overkill. I'm going to put 5 of these underneath this thing, so that way we can wheel it around and roll it around. And 5 at 375 should give me like 1,700 or 1,800 pounds of capacity, which means that if, as we're rolling it around, if the weight shifts and we get more weight onto one caster or the other or something like that, we're not going to overload a caster. Now, there are plates on the bottom of this where the rubber isolators are supposed to sit, and they are welded to the frame. So that is a perfect place to put these casters, but there's no holes in those plates. We're gonna try and be as safe as possible. We're gonna strap it down to the forklift, we're gonna lift up in the air, and I'm gonna punch 4 holes on 5 of the plates underneath there, bolt these things in with some grade 8 bolts, then set it back down and wheel it out of the way. Without casters on it, this thing is essentially a Honda Beat K car with the wheels, tires, and suspension removed. The only way it's moving from where it is with a forklift. Fortunately, we've got a Kubota with a front end loader that works perfectly. Once up in the air, I need to get under it and work on it, just like working on a car, so I need to put a set of 4 jack stands underneath it that'll keep this thing from falling down and crushing me. Now, to decide where to drill, the metal mounting plates are plenty strong, but I would like to have at least 2 of the bolts passing through the actual frame. I made up a little template of the bolt pattern of the casters, and using that, I'll mark out where to drill the holes on the mounting plates. Then I just need to punch the holes. Initially I used a stepped bit like this, but it worked all right. Later I instead drilled pilot holes and then full holes with 2 regular drill bits, and that seemed to work a little better. Either way, it's a lot of effort drilling up, and it produces a hilarious amount of swarf. To clean up the holes, I'll use a little chisel to break off the bits of metal still attached to the hole. This worked surprisingly well, no fancy chamfering needed here. Then it's just popping the caster into place and running the grade 8 bolts through it. My bolts were a little short here, so I'm running just a single lock washer. Later I went and bought some longer bolts, but these worked for now. And the "that's not going anywhere" test is really all the confirmation I need. But this was absolutely one of the most exhausting jobs I've done. By the end of it, I was breathing hard, my arms ached, and I was covered in little burns from the swarf. But I got all 5 casters solidly mounted, which meant it was time for the forklift to come back into play. A slight lift up to remove it from the jack stands, then we set it down and nothing bent, twisted, or even groaned. It just solidly set down on the casters with no problems at all. And despite weighing more than 1,200 pounds, I can now move the thing around by myself, which is an absolute win. I'm pretty happy with how this turned out. It does look a little funny, missing a caster in this front right corner here, but if I wanted to put a caster up here, I would have had to put another caster in the back directly behind it, which would have pushed my total number of casters up to 6, and I really wanted to keep the number of casters down because anytime you have to change direction with something that's on casters, you have to get all of the casters lined up in the correct direction. And the more casters that you have, the harder it is to get all of those lined up correctly. And so even with 5 here, it's still quite a bit of effort to get them all pointed in the right direction. Once they are, though, it's pretty easy to move this thing around. I think the weight distribution on this thing is about 65% on the left side and about 35% on the right side. So we have a nice triangulation of casters underneath the left side here. These are 375-pound casters, which gives us about, I don't know, 1,200 pounds of support on the left side. This entire thing only weighs 1,200 to 1,300 pounds. So we've got the 2 extra ones over here giving us extra support for the 35% of weight on this side. And I think that's gonna be plenty strong. We're gonna be able to get it into the room, and I'm gonna be able to move it around in the room with the casters in the orientation that they are. But if at any point in time it does feel a little unstable, or I can see that the casters are straining, we'll jack it up and punch some new holes and add more casters. But for the time being, I think this is gonna work perfectly. So let's move on to the next one. This is a Bendix G-15, a full-fledged vacuum tube computer from the 1950s, and this one is on long-term loan from System Source Museum over in Maryland. And if you want to see a fully functional Bendix G-15, check out the museum, because this is the second G-15 to move through the shop down here in Texas. The first one came down and we got it fully restored, fully functional. We had it playing Doom, the theme song at least. We did some cool CERN algorithm stuff on it, and then we got it installed back into the museum, System Source up in Maryland, and you can like literally go there and get hands-on with the machine and use the oldest running digital computer in North America. So this one is back down here so we can get doing some really cool stuff on it, because this is an alphanumeric model, and so we can start using the full alphabet, which is kind of a fun thing. But most importantly, this one has a crashed rotating drum memory on it, which means we got to pull that thing apart and figure out what the coding on it is. Hint, hint, wink, wink, JAMP 10S. Figure out what the material is. We think it's titanium, but we want to maybe do some X-ray fluorescence on it and really figure that out. And then recode it lay down new clock tracks, new timing tracks, and essentially create a brand new rotating drum memory for this. But the first step in all of that is getting this into the room so we can clean it up and really start getting to work on it, which means it needs casters, because the casters that are originally on this are riggedy wrecked. They are rough. So we got to rip those casters off, and I've got 4 new casters here. These are 330-pound casters. This entire thing weighs in at about 950 pounds. So just 3 casters will cover the full weight of the machine, but obviously we're going to put 4 under there. So we have plenty of caster strength for it. The only problem is well, this footprint, this footprint does not match the footprint of the original casters. I've got 2 of the original casters here right next to 2 of the new casters that are going on. These are actually from the previous G-15, and they fared a little better than the ones that are currently on there, but what a weird design. You've got kind of this double wheel setup that has very tiny wheels, and then you can see the footprint for the mounting plate is itty bitty. It's like maybe 1.5 inches square, whereas our new 330-pound casters that are going underneath there have a much wider base plate to more properly distribute the load. These feel wholly inadequate, but I don't know, apparently it was fine in the 1950s, so it is what it is, but we're certainly not putting these back on there. The problem is that the footprints are so wildly different that we got to somehow adapt this wider footprint to the holes on the G-15 for this smaller footprint. And unlike the JAMP 10S over there, I am not comfortable drilling new holes in the bottom of the G-15 here, because this is a pretty historically significant machine. I mean, there's only one functional in the entire world, and there's only about 15 known surviving examples of this. So I don't want to punch new holes in this thing, so we're going to have to build an adapter plate. And I'm going to do that with this giant chunk of steel right here. This is pretty much the exact width of these casters here. So I'm going to cut this into chunks of 4. We're going to drill holes and thread them so that the new casters can go into them. And then we're going to place this underneath there and punch 4 new holes and thread those, so that way the original bolts can bolt into this and the new casters can bolt to the bottom side of it. I realize it's probably not a great explanation, but once I get into it, it'll make sense. The only issue is that around those 4 bolt holes on for the original casters, there's also a ton of bolts going through to hold down transformers and chokes and stuff like that. So these may not fit underneath there. This is going to be kind of an interesting battle. I may have to like tweak or twist them and put them at odd angles or something. But I think the first step is going to be, at the very least, getting 1 block cut, drill the 4 holes in and thread that, and then see where we can put it and use that kind of as a test piece for all of this. And then hopefully we can get all 4 bolted on and get this thing rolling around, and we can get both of those into the room. I specifically chose this chunk of steel because it's the exact width of the casters, but I still need to slice it lengthways. So I'll set a caster on top and make my mark, then it's over to the bandsaw. And I got it cutting, but man, was it not easy. Our bandsaw is in need of a full teardown and rebuild. The motor didn't want to start. We had to give it a bit of a boost by hand, and no, it wasn't the start cap. I replaced that. Once it was running, it appeared to cut fine, except it got really hot. 66 Celsius is about 150 Fahrenheit, and that feels a little too spicy for me. Toss in the fact that our pneumatic cylinder is completely pooched and oil is just slipping right past all the seals, and cutting these out was a bit of a pain for sure. I need to start a second YouTube channel where I just repair, refresh, or restore all the tools in the shop. At any rate, I managed to babysit the thing long enough to get all 4 steel adapter plates cut out. And despite the issues, it still cut these rather well. There was just a tiny little bit of a sharp edge, but running over that with the file meant that I wouldn't have to sacrifice too much blood on this project. I mean, I had to sacrifice some blood or else nothing would work at all, but you know, only enough to keep the computer gods happy. Before I can start drilling holes, I need to know where to put the holes on the plates, which means I need to remove the original casters. I'll start on the front right of the machine, but to get the caster out, I gotta first remove this transformer because 2 of the 4 caster bolts are directly underneath it. With the transformer out of the way, I can then remove the 2 bolts and get the original caster out. Then I'll hold the adapter plate in place, mark it, carry it over to the vise, and center punch my marks. The center punch helps keep my bit perfectly lined up while on the drill press, and I'll use some nice cutting oil to make sure the bit doesn't get too hot. Compared to the JEOL, Drilling these was an absolute walk in the park. With all the holes drilled, I just need to tap them. The original bolts are going to thread directly into these plates from the top. The thickness of the plate works out such that we have more than adequate thread engagement without pushing all the way through. With one plate down, it's time to repeat the same procedure for the rest. On the front left though, it's really hard to get to the caster. First, the rotating drum memory actually has to come all the way out. This one is already crashed, so I'm not hugely worried about injuring it, but still, it's a 60-pound chunk of aluminum and titanium. Once the drum is out of the way, the two stacked chokes that completely cover the caster can be unbolted and moved out of the way. And finally, after all of that, we have access to the 4 bolts for the caster. Bendix clearly put this thing together in a specific order.
So earlier when I said that the casters on this thing were riggedy wrecked, this is the one that I was referring to. Oh, that's rough. You can see somebody absolutely hammered this thing, and this is why I felt that the original casters were wholly inadequate. We're definitely going to replace this with something much better.
We still have one more caster battle to fight, and that's the left rear caster. It's completely underneath the preamplifier chassis, so we have to very carefully loosen it up, remove it, and slide it out of the way, which finally gives us full access. I can now place the new adapter plate underneath and mark out where the holes should be. Then it's back over to the drill press to punch those holes out, followed by some more tapping. You'll be happy to know that in the 32 total holes I had to drill and tap, I only broke 1 tap. That's a new record for me, I think. But we're not out of the woods yet. I mentioned earlier that there are a lot of other bolts for transformers and chokes that are very close to the casters. I need to clearance out some space on these adapter plates for those bolts. Fortunately, the mill can make pretty quick work of this task. Well, quick relatively. I hate machining steel, so I just took small bites and took my time, doing it all by hand using the DRO. In the end, we have these 4 unique adapter plates. All we gotta do now is bolt everything together. But like the JEOL, I gotta get the G-15 far enough into the air to get under it. This forklift is getting a proper workout on this project. With jack stands securely in place, I just need to climb under and bolt everything up tight. I reused the original mounting bolts from the G-15, and then the casters are bolted to the adapter plates using grade 8 bolts. With everything torqued down nice and tight, the casters are super rock solid and have no problems holding the G-15.
And there we go, 4 brand new casters on the G-15. This thing is an absolute breeze to move around now. All we got to do now is get it into the room. But here's where things get tough, because the shop is an absolute wreck, so I need to clean that up. In order to get this into the room, there's a lot of things in the room that got to come out, because we also got to get the JEOL into the room as well, the JAMP 10S over there. It's massive, which means even more in the room has to come out. And actually, I think the current layout of the room is just flat not gonna work. I'm gonna have to move the Centurion away from the wall that it's currently on. The G-15 may not be going back into the same corner that the other one was in. Things are gonna get real chaotic. And if that sounds like a tremendous amount of work for a single person, you're right, it is. I'm gonna need some help.